Welcome to EduDisk. Today we are going to discuss the topic trigonometric identities, which is one of the important topics of the chapter Introduction to Trigonometry. Now, in this chapter, Introduction to Trigonometry, if we see, we have three important topics. One is trigonometric ratios, in other words, trigonometric ratios of some specific angles, and the third one is trigonometric identities. Now, this is very important, and how to remember these trigonometric identities and how to do the questions based on these trigonometric identities. So today we will see how to remember these trigonometric identities and how to do. And most of the questions are prove that some LHS equal to RHS. So how to do it? How to proceed with these type of questions? So what is meant by trigonometric identity? What is meant by an identity? We all know an identity. Already we have learned the identities like a plus b whole square is equal to a square plus 2ab plus b square, or a minus b whole square is equal to a square minus 2ab plus b square. Several algebraic identities we have learned. Now these identities means is a mathematical equation where is always true for all the values of the variable. It will be always true for whatever value of the variable. So that is meant by an identity. So if it is a trigonometric identity, then it is an identity related to trigonometric ratios, which is always true. Or for all values of the angles, these identities will be true. Now, which are the trigonometric identities? We have three trigonometric identities. They are, first one is sine square theta plus cos square theta is equal to 1. Second one is sec square theta is equal to 1 plus tan square theta. And the third one is cosec square theta is equal to 1 plus cot square theta. Now we will see how to remember and how to do these or how to form these trigonometrical identities. Now here see, in a right triangle ABC, if we take ABC as a right triangle, right angle at B, this acute angle A, this is the acute angle A. Now this is the opposite side. If we take as opposite side, this is the opposite side. And this is the adjacent side for the angle A. And this is the hypotenuse, right? So here we know that by Pythagoras theorem, base square plus altitude square is equal to hypotenuse square. So we can write like this, O square plus A square is equal to H square. Now divide throughout by H square. Divide throughout by H square. So O square by H square plus A square by H square is equal to H square by H square. That is O by H the square plus A by H the square is equal to H square by H square is 1. Opposite side divided by hypotenuse, that is sine. Sine of the angle A here, so sine square A, plus adjacent side divided by hypotenuse, that is cos A. So this is cos square A is equal to 1. This is the first identity. That is sine square A plus cos square A is equal to 1, or for any acute angle theta, sine square theta plus cos square theta is equal to 1. First identity. Now, from the first identity, how to get the second identity? Divide each and every term by cos square A. Divide each and every term of the first identity by cos square A. So sine square A by cos square A. Sine divided by cos, that is tan ratio. So sin square A by cos square A is tan square A plus cos square A by cos square A is 1 is equal to 1 by cos square A. 1 by cos is, or 1 by cos theta is sec theta. So this will be sec square A. This is the second identity. So you got the second identity. Now for getting the third identity, the same thing, divide throughout by sine square. First identity itself, divide throughout each and every term by sine square A. So sine square A by sine square A, which is 1 plus cos square A by sine square A. Cos divided by sine is cot. So this will be cot square A is equal to 1 by sine square A. 1 by sine is, that is the reciprocal of sine is cosec. So cosec square A. So this is the third identity. So we have got all the three identities. First one is sine square A plus cos square A equal to 1. Second one is sec square A equal to 1 plus tan square A. And third one is cosec square A is equal to 1 plus cot square A. Same thing is explained here, dividing each and every term by the hypotenuse square, that is AC square. We will be getting like this, which is sine square A plus cos square A is equal to 1. Similarly, if we are dividing by AB square, that is this side A square, then we will be getting 1 plus tan square A equal to sec square A. And similarly, we will be getting the other one as well. So these are the trigonometric identities. So you can write, remember like this, and you can write the trigonometric identities. And these trigonometric identities, so from this you will be getting sine square A is equal to 1 minus cos square A. Similarly, cos square A will be equal to 1 minus sine square A. From this one, tan square A is equal to, you can write it as sec square A minus 1. Similarly, sec square A minus tan square A equal to 1. So you can rearrange and write these identities as according to the need of the question. Now we will see few questions, how to do the questions related to these trigonometric identities. So this is one of the examples. Prove that tan square A plus cot square A plus 2 is equal to sec square A into cosec square A. The first thing that you check here is all these questions, either this is the LHS, this is the left hand side, and this is the right hand side. So there are three methods to prove such questions. One is starting with the LHS and reach the RHS. Or you start with RHS and reach the LHS. Or if you find both difficult, you can even simplify the LHS and simplify RHS, and both must be same. So these are the three techniques to do this type of questions. Now, if we are starting with LHS, suppose here the LHS is tan square A plus cot square A plus 2. And RHS sec square A and cosec square A. So we can understand that this tan and cot must be, or tan square A and cot square A must be converted in terms of sec square and cosec square. So you can use the identities, that is tan square A plus 1 equal to sec square A and cot square A plus 1 is equal to cosec square A. These identities you need to remember. But that 1 is not there, but there is a 2. So this 2 you can split and give 1 here and 1 for cot square A. So tan square A plus 1, this together we can write, and cot square A plus 1 together. 1 plus tan square A is sec square A and 1 plus cot square A is cosec square A. Now you got it as sec square A plus cosec square A. But what do we need? It is sec square A multiplied by cosec square A. So still we need to simplify. Again, sec square A is 1 by cos square A plus Cosec square A is 1 by sine square A. Take the LCM. So we will get as sine square A plus cos square A. Sine square A plus cos square A whole divided by sine square A into cos square A. Again, the next identity, sine square A plus cos square A is 1. So 1 divided by sine square A into cos square A, which is 1 by sine square A into 1 by cos square A. That means cosec square A, 1 by sine square A is cosec square A into sec square A. Now we got the RHS. Similarly, if we want, we can take the RHS. So sec square A into cosec square A we can take and change this into this. That means sec square A, you write it as what is sec square A is 1 plus tan square A multiplied by 1 plus cot square A. Then multiply together, then also you will be getting the answer as, or you will reach the LHS. So whichever is easy that you can adopt, that means either start with LHS and reach the RHS, or start with RHS and reach the LHS, or simplify both and reach the same answer. Another example. Prove that cos raised to 4a minus sine raised to 4a is equal to 2 cos square a minus 1. Again, you can see here it is of the form a raised to 4 minus b raised to 4. One thing for doing most of the identities here, we need to know the basic algebraic identities, that is a square, like a square minus b square. What is a square minus b square? It is a plus b multiplied by a minus b. So this is the identity used here. But it is, so if it is a to the power 4, we have done this type of question in algebraic identities. If it is a to the power 4 minus b to the power 4, this can be written as a square the whole square minus b square the whole square, which is again equal to a square plus b square into a square minus b square. So this identity actually is used here. So cos raised to 4a is written as cos square a the whole square, and sin raised to 4a is written as sin square a the whole square. So this of the form, this a square the whole square minus b square the whole square, which is a square plus b square into a square minus b square. So cos square a plus sin square a into cos square a minus sin square a. Again identity, cos square a plus sin square is equal to 1. Cos square a plus sin square a equal to 1. So again remaining is cos square a minus sin square a. Just have a look at the RHS. RHS is 2 cos square a minus 1. There is no sine term. So again this should be changed. The sin square a should be changed in terms of cos square a. So the sine square a, again use the identity, sine square a is 1 minus cos square a. Do not forget to put the bracket, because cos square a minus of 1 minus cos square a. So cos square a minus 1 minus minus, that is plus cos square. So twice cos square a minus 1. 2 cos square a minus 1, which is the RHS. So we got the RHS. So this is the way of doing, and each and every problem there will be an easy technique for doing the question, which if you know how to do the question, it will be very easy. So you need to practice the questions like this, so that will be easy. One more example we will see. Tan raised to 4a plus tan square a is equal to sec square a, sec to the power 4a minus sec square a. As we discussed before, here also this LHS is purely in terms of tan and RHS is purely in terms of sec. So it is obvious that we need to convert tan to sec. And we have the identity tan square a. Tan square a is equal to, tan square a is equal to sec square a minus 1. So here tan square a is common. In these two terms, tan square a is common. So we can take it outside. So LHS equal to tan square a into bracket tan square a plus 1. So 1 plus tan square a. Again, this minus 1 when it comes here, 1 plus tan square A. 1 plus tan square A is equal to sec square A. And here tan square A is equal to sec square A minus 1 because there is no tan term in the RHS. Both the tan square we need to convert in terms of sec square. So this tan square A we write it as sec square A minus 1 and this tan square A plus 1 we write it as sec square A and multiply together. So we'll be getting as sec to the power 4A minus sec square A, which is the RHS. So we can easily prove that it is the LHS equal to RHS. Now, these are the common types of questions. There are many different types. You may get any question related to this, but if you know the identities properly and how to convert from one type to another one, then we will be able to do these type of questions. So hope you have understood the concept of trigonometric identities as well as how to do the questions related to trigonometric identities using the technique that is start with LHS and reach the RHS or start with RHS and reach the LHS or start with both and simplify and get the same answer. Hope it is clear. Thank you.